Hello, everybody in our webinar, everybody to join the afternoon session. A very warm welcome. And the afternoon sessions are related to the very important key components for single-pair Ethernet systems. These are the semiconductors. And all the customer meetings I attending in the last year, the question for the right semiconductors is one of the most often heard questions at all. And that's why we are very happy to have Gabriel Meier and Torsten Rothe with us today from Avnet Silica. They will give us a very good overview about the products available already from the main semiconductor suppliers. And hello to Gabriel, I hand over to you and the stage for this presentation. Now it's yours. Thanks.
I'd like to welcome you to this presentation about the semiconductor solution we can offer to you for single-pair Ethernet. My name is Gabriel Meier. I'm the market segment manager at Avnet Silica for smart industry. So looking after the industrial automation market at Avnet Silica, providing solutions with our suppliers to you, discussing with customers, give the feedback also to suppliers what you need in your application so that the right silicon will be there for you in the future. With me today is Torsten Rothe, Senior Field Application Engineer, which will go down to the products later on. But first, let me quickly go through the agenda for this session. We will have a brief introduction, which we just are about to do. Then we go into a system overview of the building blocks needed for single-pair Ethernet. And of course, in the main part, we will show you the products which are available on the market right now, and then also do a demo that you can see that everything is there, that the tools are there, that you really can start with your development. Maybe because not everyone in the audience is or knows Avnet Silica, I will just briefly introduce Avnet Silica to you. We are a distributor, a leading design-in distributor here in Europe, and are part of the Avnet Corporation, which is a leading global distributor based in Phoenix, USA. In Europe, we do about 2 billion euro revenue and have, of course, offices all over Europe, all over EMEA, with supporting you, especially with technical engineers. So we have over 200 engineers in the field to support you in the designs and give you the latest information on the silicon products we offer from the major silicon suppliers in the world. We are not only supplying just silicon, more and more we moved to a technology and system solution provider, offering a lot more around the silicon itself, including services as well, which I just will show you on this slide actually. So really moving from silicon to cloud, offering you a complete roadmap and solution to cover the whole system. So of course, the edge and the silicon is still our key focus. It's key that we have some silicon there, but on top of that, we're offering, of course, the latest technology. We offer turnkey solutions. That means giving you a quick start into your design. Additionally, we can also offer embedded hardware and software design with some acquisitions we did over the past years, either in-house or also with third parties to speed up your designs and help you out if there is any lack of resources on your side. Also, a big topic which is in our focus is artificial intelligence, machine learning at the edge. So on CPUs, MCUs, bringing that technology onto the edge. Of course, connectivity is key. That's what we are discussing today. And then, of course, also through an acquisition we did 2 years ago, we are able to offer complete cloud solutions with our own IoT Connect platform, which is based on Microsoft Azure. with data centers all around the world, also here in Germany under the European or German GDPR rules, and they are certified as well. Also in this space, we can offer a development and of course consultants services, so to help you integrating your products from single pair Ethernet, from the sensor really to the cloud as well. In the cloud, of course, there is we offer software as a service solutions for analytics, for dashboards, complete ready-to-use solutions for various application and use cases, and of course as well AI platforms to implement analytics there as well. And last but not least, security, end-to-end security from the device up to the cloud is of course also fully integrated and available.
Hello, Gabriel. Sorry for interrupting. Can it be you are still on the first page? We see only
I'm actually on the slide called From Silicon to Cloud, which is the second, I guess.
Yeah, we see just the beginning page and now no page anymore.
Okay.
This is coming up in the question slides.
Somehow it stopped. It just now, just in this moment, the window popped up on my screen. Share again.
Yeah, that is now the right one.
Okay.
We are on the right. Now we from Silicon to Cloud. So sorry for interrupting.
Okay.
But yeah.
No problem. I don't know what happened. Okay. Might be careful not to touch anything here. So as I mentioned on this slide, we can really offer you the complete ecosystem, the technology expertise, the turnkey solutions, the silicon, but also software development, consultancy, IoT or cloud services, enterprise platforms, and of course, a huge partner program behind that as well. You can join that or use those partners for your designs, of course. So moving to the next slide, which is the key topic, single pair Ethernet. As we heard over the 2 days already, it's really a key enabler in Industry 4.0. It brings Ethernet to the last mile, down to the field level actually. And it has a lot of advantages. It eliminates all the field bus gateways. It gives a seamless integration, Ethernet and IP communication all the way down and up to the cloud. So simplifies the integration in big systems. And of course, there is a huge ecosystem, Ethernet-based ecosystem behind, which you can use also down to the field level as well. It enables, of course, a lot of new use cases when you directly can connect sensors and actuators to the Ethernet IP connectivity. So actually moving from, let's say, that sensors just provide measuring values to control the process and the automation, really delivering this data to a data lake, which then can be used to do big data analytics, use AI technologies, and enable data-driven business models as well. In a single pair Ethernet system, or generally in an Ethernet system, so Ethernet is used in industrial automation a lot already, of course. Now we can use single pair Ethernet, and this is just an example diagram what you could do with single pair Ethernet and where you need new components. We'll see that in a moment. So on the left side we have the 10 megabit Ethernet topology with T1S or T1L. Then we can of course also mix that with classical Ethernet and have the other speeds like 100 megabit and gigabit Ethernet or even daisy chain solutions as well. So of course, for every node, we need the single pair Ethernet physical layer. So it's a new physical layer, Ethernet physical layer we have here. So every node is actually using an Ethernet PHY, a T1 PHY, with various speeds and lengths. And in between, of course, we need Ethernet switches to connect the different speeds, the different nodes together and manage the whole network then, of course. On top of that, you need, of course, CPUs, software, MCUs, the analog front end for sensors and so on, where we can, of course, help you as well. On the next slide, we have seen this a couple of times in over the last presentations. Just want to recap that again, showing the different speeds, which we know already from the classic Ethernet. On top, with single pay Ethernet, which is a little bit special, we have different lengths we support, up to 1 kilometer on the T1L, for example. That's a little bit different to the classic Ethernet, where we usually have the 100 meter for T and TX based Ethernet systems. Also here with T1S, we have a so-called multi-drop, multi-point to multi-point structure, where we can hook up multiple sensors to a bus system, basically, with 25 meter and at least 8 nodes. The standards, some of the standards just have been released or finalized recently. So that means that silicon for those new standards is sometimes still in development. Some first silicon is available, but for the latest standards, of course, it's under development. Because, of course, for the major silicon manufacturer who actually are involved in the IEEE standardization as well, for them, it's of course a multi-million investment to develop silicon, and they will do that, of course, when the standards are mature and actually released, because they need to base on that to have the reach in the market and have also then the possibility to get a return to their investment. So that's why we will see a lot more silicon coming over the next months and years from the suppliers. On this slide, I just want briefly to compare the differences between the classic Ethernet, so the 1x gigabit Ethernet with the T1 gigabit, for example, and as well on the 100 megabit Ethernet. So one of the main differences we can see here is, of course, on the line coding, on the modulation, which is different from the classic Ethernet. So in the 1000 base T1 as well as the 100 base T1, it's a PAM3 modulation which is used compared to a PAM5 or MLT3 on the classic Ethernet. Also, there are some differences with the DSP implementation. So we have forward error correction implemented on the T1 single pay Ethernet PHYs. Of course, the length is different. On the classic Ethernet, we have the 100 meter, and with the single pay Ethernet, we have 15 or 40 meter, depending if we are using shielded or unshielded cable. And also on the power side, there is a difference, of course, in the standard because we use the PODL for power delivery over the single pair. And you can see, because we are moving to a single pair instead of having 4 pairs on gigabit Ethernet, classic gigabit Ethernet, of course, the frequency is increasing a lot, which of course will have an impact on the cables and connectors, what you have seen also in some other presentations today, or let's say yesterday. So for the future, suppliers are of course also thinking to expand the reach. So for example, for 100 base T1 and 1000 base T1 to come up also with products and solutions to reach 100 meter. So actually expanding the standard. So that's also a little bit what the last presentation touched a bit from Enders and Hauser, with some expansion there in speed and length. So that's ongoing as well, but of course that's something for the future. So with this brief introduction and overview in general, we want to move on now to the products which are available in our portfolio to support single-pay Ethernet. And for that, I will hand over to Torsten Rothe to give you the details on the products.
Hello and welcome also from my side. My name is Torsten Rothe and I like to introduce you to the portfolio of Avnet Silica. In the meantime, I will share my screen. Let me check if I can share this. Does anyone can see my screen?
Take your time. It's not the presentation screen. It's the moderator screen you have at the moment.
Oh, okay, now that should be better.
It works fine.
Okay.
Yeah, take your time. We have it.
Okay.
No,
so
it works fine.
I think I'm prepared, so we can start.
Exactly.
Thank you for inviting me. It's really a pleasure to present you today our portfolio, which we have in the meantime. And let me start with this slide, which shows you or which gives you an overview about our suppliers, which we can offer T1 solutions today. We have 4 suppliers with Microchip, onsemi, NXP, Marvell, which already have the products in mass production or on their roadmap. The more manufacturers, the more standards are supported, and interoperability will be improved. Marvell has the broadest portfolio on our line card. Some T1 PHYs support only one speed, some support multiple speed like 1000 base T1 or 100 base T1. T1 segments with different speed standards cannot be connected together unless multi-speed PHYs are used with correct configuration setup. A switch is needed in between to link segments with different speeds or standards. Let's start with Microchip. The Microchip PHY is one of the first in the 10-base T1S market and offers the possibility to connect more than one device together in a bus line. In this case, up to 8 devices can be connected on a bus line with a maximum length of 25 meters. It is a shared medium with half duplex communication. To avoid collisions and get full bandwidth utilization, the T1S implements the file-level collision avoidance mechanism, which is controlled by the bus master. The rest of the technology is fully transparent for IP traffic as in every Ethernet-based system. The device will have the typical standard interface like MRI or RMI and can be connected to the MCU, Ethernet switch or any other device with an Ethernet media access controller included. Like power over Ethernet, power over data line is often a topic, as in this case here. We don't have further information, but IEEE working group is in the power definition status for the 10-base T1S standard, which will be different from the power over data line standards as we see today. The process is ongoing. Hopefully, we can expect some more information during the next year. With the LAN 8770, Microchip offers 100 base T1 Ethernet PHYs. It is a fully compliant device to the IEEE 802.3 BW standard and will work together with PHYs from other suppliers. Compared to the 10-base T1S, it is a single point-to-point connection and no bus line. In this generation, we have the termination and filtering already included in the device. It is no longer needed to do this external. All major vendors will follow this trend because the external termination can make this connection sensitive to external interference. Again, as in the previous slide, the PHY comes with the standard MRI, RMI, and RGMI interface depending on the package size and can be connected to every device with a standard Ethernet MAC, like MCU or switch. Microchip has some more devices on their roadmap, but these products are still under NDA. The company is well known for their portfolio of industry Ethernet products and famous for the longevity concept. These are the available evaluation boards. The first picture is one of the plug-in boards with RMI and it's compatible to the Ethernet development kit from Microchip. It is available today. The second picture shows a converter solution from RG45 100 base TX to 100 base T1 with screw connectors. From my point of view, it is the easiest way to start with. There will be a graphical user interface configuration tool based on the MPLab tools, especially for network solutions. We expect to have this board and tools in December timeframe. NXP was one of the first adopters of 100 base T1 standard for the automotive vehicle network. The TJA1100 and the TJA1102 are fully compliant to the IEEE 802.3 BW standard. The PHYs come with a standard MRI, RMI and can be connected to a standard Ethernet MAC. The TJA1102 can work as a dual PHY solution and offers repeater functions. The RMI interface can work in reverse mode so that you can connect both internal PHYs back to back and enlarge the cable distance. This is already the second generation of NXP PHYs and therefore they offer internal termination and ESD protection. Also, NXP has plans to develop new devices in the near future. The switch from NXP has nothing to do with the 100 base or 1000 base T1, but I still think it's worth mentioning this device. It is a 5-port full gigabit switch with no internal PHY and different MRI interfaces. Depending on the derivative, it can be MRI, RMI, RGMI, or SGMI. That makes the device interesting for T1 solutions. You could combine classic Ethernet like 1000 base T with 100 base T1 just by connecting the right PHY to the switch. That gives you the possibility to build something like a gateway between the different standards. The switch offers additional typical features like VLAN support, MAC address table, and some AVB and TSN features. Here are two examples of the evaluation boards. Both can be configured via jumper settings. They offer the typical interfaces MRI, RMI for connection to an MCU or SoC or a switch. There are screw clamps for easier use and you don't need any vendor-specific connectors. The second board with the TJA1102 could be used as a dual PHY or as a repeater. To test the NXP T1 solution, there are two evaluation boards. Both of the switch evaluation boards could be interesting. The switch on both boards is the SJA1105, which was mentioned on the previous slides. As you can see, the second board comes with 2 times TJA1102 PHYs, which offers up to 4 times 100 base T1. Unfortunately, there is no RG45 connector on board for 100 base TX or 1000 base T. But it gives you an easy entry to the topic because everything can be configured from host PC via USB. Now we start with Marvell. Marvell has the broadest range of products, PHY products in our portfolio. Therefore, I will only mention some of the devices here. The 88Q1010 was one of the first 100 base T1 products in the market. They are fully compliant to the IEEE standards and interoperate with other vendors. It has a pin-out which is compatible to many other devices in the Marvell family, which makes it easier for further redesigns. All devices, the typical standard interfaces with MRI, RMI, RGMI can be connected to an MCU, SoC or switch. Especially the integrated standard MDIO makes it easy to implement it into a switch solution. The single supply voltage is one of the advantages which supplies the design. This is already the second generation of 100 base T1 PHYs from Marvell. The 88Q1110 device supports reduced pin count, RGMI and RMI, on media-independent interface. The Q1111 device also supports the CGMI, SGMI, for direct connection to a MAC or switch port. SGMI operates on a 1.25 gigabit over a single pair. It reduces power and number of IOs used on the MAC interface. All devices have integrated termination resistors on the media-dependent interface. The resistors integration simplifies board layout and reduces number of external components. The device can run off a single 3.3 volt supply. Both the Q1110 and the Q1111 is designed to support frame preemption per IEEE 802.3BR, which is one of the TSN standards. Marvell 88Q2110 and 2112 implements the Ethernet physical layer option for 100 base and 1000 base T1, as the standard is defined by IEEE 802.3 BW and IEEE 802.3 BP. All the devices in the previous slides, the Q2110, Q2112, have integrated resistors on the media-dependent interface. Also, they support an integrated linear voltage regulator to generate all required voltages, so the device can run out of a single 3.3 volt supply. Again, here we have some devices which are pin-to-pin compatible, which helps in the design phase to reduce the development cost. There is a 88T2112, which is software and hardware compliant industrial version of the 88Q2112. Both can handle 100 and 1000 base T1. Marvell plans further designs based on MAC security in the future. The Marvell Q5050 is one of the first switches in the market which offers integrated 100 base T1 PHYs. The switch itself is an 8-port switch with a full gigabit switch engine inside. As you can see, the switch has integrated ARM Cortex-M7 CPU and can handle trust boot and hardware keys to validate software images. It is possible to have a secure switch solution. The internal TCAM offers deep package inspection at wire speed. Via the remote management unit, it is possible to configure and monitor the switch from outside. The generic interface allows the connection of additional PHYs and thus a transition to classic Ethernet, which we'll then demonstrate during the demo later. Also, this switch stands for a larger family of devices. For example, the 88Q5030 is a lower port pin and pin-to-pin compatible version of the 88Q5050. Other devices are available and further devices are on the roadmap. The 88Q1010 evaluation board is a typical converter board. It works either in slave or in master mode on the T1 line side. MDIO is accessible through the USB to SMI adapter and some software, GUI or command line tool. We will see this later in the demo. A similar board is available for the 1000 base T1 solution. It is based on the 88Q2112. This is the development board of 88Q5050, and it will be shown soon in a short demo. As you can see, it comes fully assembled with a switch and up to 5 integrated T1 PHYs, 2 external 1000 base T1 transceivers, and 1 standard 1000 base T RG45 port. It is configurable via DIP switches, has EEPROM and quad SPI on board to store firmware and customer configuration. There are some software tools from Marvell to change and debug the configuration. From my point of view, that's a really good choice in conjunction with the T1 converter board to start into the topic of single pair Ethernet. That's a block diagram of our demo. I would suggest to start our short video and hand over to Gabriel. Is our demonstrator for 100 base and 1000 base T1 solutions from Marvell. Usually that is part of a demo case, which we use together with interested customers to showcase the T1 technology and give them an easy start for their development. In the upper right corner, we have the 88Q5050 switch evaluation board. It's a 8-port switch with up to 5 internal 100 base T1 transceivers, 2 external 1000 base T1 transceivers, and 1 external 1000 base T1 PHY. The firmware is running on an internal Cortex M7. On the lower side, there are 2 88Q1010 converter boards. For this demo, we will only use one of those. On the lower left side, it's an espresso bin community board with a Marvell SoC based on a dual Cortex A53 and a classic Soho switch 88E6341, which will act as a server for our demonstration. In the middle of all these boards is a USB to SMI adapter, which is useful for debugging the boards or make some configuration changes. We will demonstrate this later. Before we start, we must configure the boards. In this demonstration, the Q1010 converter board is connected via standard RJ45 cable with the espresso bin board. The converter board is configured in slave mode. On the 100 base T1 side, it is connected via the green cable and some normal screw connectors with the Q5050 switch evaluation board. The reason for using screw connectors is quite simple. We have different connectors on 2 boards. One comes with Rosenberg and the other one comes with Amphenol connectors. The green cable is made for single pair Ethernet. This type of cable is already available as standard product in the market. The Q5050 switch evaluation board is configured in master mode on all 100 base T1 ports. And in addition to this, the port 8 with RJ45 is in remote management mode. The remote management port will help us later to get access to the switch and read out the status or configuration of the switch. The configuration of master and slave on both sides is necessary because auto negotiation, like in the standard Ethernet, is not possible so far. You always have to make sure that one side is a master and the other one in slave mode. The T1 standard is coming from automotive industry, and in a car, which is a closed system, there is no need for auto negotiation. In the first step, we use the automotive switch GUI to access the switch. It is called automotive switch GUI because it was first used for automotive applications, and the name was never changed. As you can see, we select the corresponding Ethernet adapter and access the switch through the port 8, which is in RMU mode. Now we are able to change the configuration or to set the package inspection via TCAM. The switch is fully accessible via RMU, but only if you put the switch into this mode. If someone of you knows the Marvell switch GUI for Zoho switches, we have some good news for you. Since August, the standard switch GUI supports the automotive switches as well. For this, we connect the board with a USB to SMI adapter. Now we have a communication path via MDIO to the switch and get access to all registers and counters. Let's have a look. The same USB to SMI tool can be used to debug the converter board via SMI Automotive GUI. As you can see, there are many evaluation boards and debug tools already available, so you can start your test and development right now. As a last demo, we would like to show that the new technology is fully transparent on a physical layer with a short performance test. The espresso bin is acting as a server and our PC as a client. The packets will run over the switch and the two 100 base T1 files without any impact on the transfer rate. Single pair Ethernet will have for sure a huge impact in the industry and help to save cabling and installation cost and bring Ethernet to the field level. It will not replace the classic Ethernet. It is an addition and evolution.
Thank you very much, Torsten, for putting this demo together. I think it's a really good possibility to show that also to customers, to bring them the technology into their hands so that they can experiment and start design development with this starter kits and development kits from Marvell. Let me just briefly summarize. So as you have seen in this brief overview on the available silicon, the time is ready to start your design. Products are there and a lot more are on the roadmap to come. Some of them, of course, are still under NDA. But if you start your project, please talk to us. Our experts will support you with your designs, suggest you the right products, help you with the NDA stuff and get access to more data from the suppliers so that you can really develop your application with the development platforms which are already available. To contact us, it's very easy. Use your existing Avnet Silica contact if you have one. If not, then here's a link to our website with all the locations we have all over Europe, or just simply drop Torsten or myself an email, and we will link you with your local contacts to start your development. So now I think it's time to open question and answer round. So please type in your questions if you haven't done so, and we help you out to answer it.
Yeah, first of all, thanks from my side and also in the name of all these participants. So it's really a nice and big group. And we have already some questions here where we can look in. So I start with the first question. Somebody type into the question window, and this is a question: when will the T1S products will be available? So this T1S is a 10. It means the 10 megabit T1S products where we see they are available.
Yeah, okay, the T1S product, because the T1, let's say the 10 megabit standard has been released end of last year, if I remember correctly.
Yes.
So that's also the reason why, of course, the silicon is still somehow under development. There are customers, especially for automotive, which have first silicon, but let's say the general availability will be someone mid of next year. So in summer time frame next year.
And as you've shown up, it comes from Microchip and Marvell so far, yeah?
And on Semi, we have three
And on
suppliers.
Semi, yes.
Plan to have
okay.
it.
Yeah.
Okay, thanks for this. There's a second question, very detailed to one dedicated PHY from Marvell. It's a question. How does 88Q211X PHY detect the speed of the attached device? I think this is the PHY with the two speeds, 100 megabit T1 and 1000 base T1. Because as we mentioned, or as we know, there's no auto negotiation between the standards, but this PHY offers two speeds, and that's why the question come up how AutoNeg is working here.
Yeah, there is no real auto negotiation between the PHYs. Normally, you can do it via software, but you would configure it in a fixed mode, like a 1000 base T1 and master or slave. If you like to do something like an auto negotiation, you have to do it by software. It's not the same as in a standard Ethernet. Yeah,
so you have the PHY supports both speeds, but before you use it, you have to make the right setup. Yeah.
Yeah, that's a really detailed question. There is a software API. If you look into this, you will see how Marvell have done this with evaluation boards.
Yeah, but the person who is behind this question can also contact you directly if more is supported.
Because those things are covered under NDA. We cannot show it to you without the NDA.
But there is an answer for this. And the topic is, I was part of the IEEE. Most of the standards are pushed with very high time pressure to the IEEE committees, and with the focus on automotive, they don't realize auto negotiation and so on what we have. But as shown also today in the morning, we have an initiative, and we want to fill out the gap between reach and speed for higher speeds also, and when we can hopefully with the next standards repair this topic. Yeah, okay, there's another question related to the products you show up, and the question in detail is how do all these parts relate to the industrial use cases and not only to automotive? Yes, it's a little bit general question.
Yeah, so of course, single pay Ethernet and all the suppliers have a big focus on automotive because that's where everything started with broader reach in the past. That's why the focus is there. But of course, you can use such an Ethernet PHY also for industrial use cases. Of course, there are some limitations in the standards. You only have the 40 meters for the gigabit, for example. That's due to the standards, so you cannot overcome that at the moment. Maybe in the future. Of course, you can use the 10 megabit with 1 kilometer, but that's more than oriented to process automation, of course. So yeah, it started with automotive, but of course you can use this silicon in industrial application as well, and most of our suppliers will support industrial application as well.
Yeah, it's true. It's the case. We have some limitation for single pay Ethernet, but at the other side, also single pay Ethernet PHY chips offers today a much more better position. Like we start in the 2000 years when we start with industrial Ethernet, when all the PHY chips are manufactured for office applications. I still remember when we're offering switches and say extended temperature range and so on. This is not the case at the moment because all these PHYs are developed for automotive and they have much more environmental conditions compared to what we have in office. So that's why this is a good point. From the technical point of view, there are some disadvantages. We have not the full reach like we have it for standard people, but there are use cases. And especially if you look back to the presentations we had today in the morning, where also companies show up where the existing products can be used also for industrial use cases.
Exactly. Yeah. Yes, and as you just mentioned, from the temperature range, most of the products go up to 125 degrees.
Yeah, it's better.
Which is certainly an advantage. Yeah.
And also EMC robustness is much better compared to the point where we start with industrial Ethernet. Yeah. Here's one more question, and it's related to Poodle, and I think this is a question we have to ask every semiconductor company. What's the recommended evaluation kit for power over Ethernet or Poodle evaluation? But I think before we can answer this question, at the moment, I search also since a longer time for Poodle components, and there are some rumors under NDA, some first information, but how you see the position or the availability for Poodle components, and when what could be the nice evaluation board? Yeah.
Yes, so it's actually the case as you mentioned it. There of course are development out there. Products are on the NDA. It depends, of course, what you want to implement with regards to Poodle. If you just want to have Poodle without any communication implemented, then it's fairly straightforward. You need a power supply, of course, an inductor to couple the power in and out, and you are done. So for that, there is no special silicon needed from my point of view. But of course, as soon as you start the communication, do the full implementation, then silicon would be needed or would help. Otherwise, you have to do it by your own, implementing the software in an MCU, for example, and do everything by yourself. But yes, that's something for the future. Suppliers are working on that. And if customers are interested in that, just contact us and we can then provide some further information on that.
Yeah, but it shows the real interest from the customers in the market, because it's not only the protocol, it's also how to bring the power, especially if we want to go with single pair Ethernet to the field level where we only have the requirement for one cable and connection. I just look a little bit on time, but we're good in time. Let's look for one more question here. One question here is coming up is there any external ESD protection necessary? One customer is asking us.
Not really, but it's recommended to do this, and you can find ESD protection from different vendors like NXP, Semtech, and so on. Yeah, and if you look into the reference schematics, you will find such external ESD protection.
Okay. So far I look around, most of the questions are answers. Yeah, and also again, the invitation, if anybody needs more support and have more questions, you have the contacts from the colleagues from Avnet Silica. Feel free to contact them. And thanks a lot for everybody who was listening here. And thanks again for your presentations. It was really helpful and informative. And that's why thanks so far. So we go to a 10 minutes short break, and when we continue with the next important topic, because in between the semiconductor and the connector and the passive infrastructure, we need also magnetics, and then we will hear something about this topic. So thanks, and we stay in contact. Have a nice afternoon, and we are back in 10 minutes around. Bye-bye.
Thank you.
Thank you. Bye.